So, over a year ago, probably a year and a half ago, I posted a YouTube video on my channel about how to bypass a faulty knock sensor on a GM V8 engines. That video is there. Almost 100,000 people have viewed it. I've had hundreds of comments, most very positive. What I show you how to do in that video is for almost zero cost to bypass one of a dead knock sensor. The GM V8s of that era have two knock sensors, and one of them will typically go bad, usually the front one, because of water seepage inside the top of the engine, and it throws a code, on your dashboard. Your check engine light has a code for that dead knock sensor. What happens is you start the engine, the ECM tries to check each knock sensor to make sure that it's functioning correctly, and one of them doesn't function, and so the ECM says, whoop, I got a bad knock sensor, throws a code. And in some states you can't pass your inspection with that code, and you got to fix it. And the problem was that it's typically a $700 to $1,200 job to replace that knock sensor. You have to take off the top of the engine, the head, not the head, but the whole manifold intake, disconnect fuel lines, a lot of electrical wires. Take that whole thing off, replace gaskets, replace the knock sensors. The knock sensors cost about $100, and so forth. So a lot of people don't have that money, especially on these older engines, which date from 2000 through like 2007, I think. And so it's nice to be able to bypass it. The reason I'm making this video is several of the comments that I received expressed real concern that by not replacing the bad knock sensor, you're putting your engine in jeopardy. And that your engine will not run right. I've thought about that a lot. My engine has been running perfectly. I've driven it thousands of miles, and my engine is not knocking. The code is gone. My check engine light is off. It's like it's a new engine. It's got plenty of power, plenty of good gas mileage for the V8 engine. So my gut feeling is that my engine is not. There's no danger to my engine. I am not hearing any knocking. That's the people who have questioned this have said, without the knock sensor, the ECM is going to miss the fact that the engine is knocking, and therefore it won't adjust the timing when the engine starts to knock. And as we all know, a knocking engine will pretty much destroy itself pretty quickly. My advice in the comments has been, if you do this, yeah, you're only going to have one knock sensor, and that one knock sensor may not hear all knocks. However, a well-maintained engine, it's not going to knock at all. And if it's not knocking, the knock sensor has nothing to do, and the engine's going to run fine. I believe that's the case with my engine, and I believe that can happen for other people. But because of these criticisms and comments, I decided to do some research on whether the knock sensor is being used by the ECM on a regular basis to set the correct timing of the engine. And I believe, based on the research, that the knock sensor is not being used. And I'm going to explain why in this video. First of all, let's review a little bit what engine timing, what spark timing is all about. In an engine, you've got your piston going up and down, up and down, up and down. And as it gets to the very top, there's a spark plug. Bang, bang, bang. That spark plug wants to spark just at the right time, so that the pressure from the burning fuel, the increasing pressure from the burning fuel, just starts to kick in as that piston is just starting its trip down. Okay? If the pressure from the burning fuel is too late, like when the piston is down here, if the pressure builds at that point, it's not going to really add much energy to the piston. If the spark fires too soon, when it's too much on the way up, it's going to fire here. Pressure is going to actually slow the engine. Excuse me, slow the piston down and take energy out of the piston. So that's what we're dealing with here. So from my research with these electronic engine control units, which most cars have since about 1990, there's really two inputs that the ECM uses to decide when to fire the spark plug. One is the RPM, because the faster the engine is spinning, the faster the spark plug is going up and down. Right? The sooner the spark has to go, because the fuel is going to burn at the same rate based on when the spark fires. But the piston is going, as you go for higher RPMs, it's moving faster and faster and faster, and that means that the spark plug has to fire a little sooner, so the mixture can get through enough of the burning process so that the pressure in the cylinder is starting to build just as that cylinder passes top dead center and starts its way down. The other factor that matters is the load on the engine, okay? The load, and what the load ultimately is how much air and fuel have been pushed into the cylinder for this stroke. If you're going up a hill, you're going to be pushing down on the accelerator, the injectors and the air manifold is going to let more air and fuel into that cylinder because you need more power. And it's just a fact of physics and chemistry that when you have a denser fuel air mixture in that cylinder and you ignite it, it's going to burn faster. So as you're increasing load on the engine, let's say you're running at 3,000 RPM, steady level of RPM. Based on that RPM level and speed of the engine, the ECM is going to fire the spark plug, let's say 12 degrees in advance of the piston getting to the top dead center. Well, if now you put much more load on the engine, meaning you're putting more fuel air mixture into that cylinder, it's going to burn faster. So that means that the timing can be retarded a little bit. So it doesn't have to be at 12 degrees. It might be better to go at 9 degrees top dead center, because even though it's spinning fast at 3,000 RPM, the fuel air mixture is going to burn faster, so it can wait a little while before it sets off the charge. So what these ECMs have in them is they have a table, and the table across the top has the RPMs from 0 to 5,000 or 6,000, and down the side they have engine load, and that's a number that gets derived from the mass airflow sensor, the throttle position, and things like that, which measures how much load is being demanded of the engine, therefore how much fuel is being pushed into the cylinder. And that'll go from a number of like 1 to 10. And as that gets higher, as that load gets higher, if you notice in the chart, the timing for the spark plug, if you look down a column under 3,000 RPM or 4,000 or 5,000 or 2,000 RPM, you'll see as the load goes up, the timing gets retarded a little bit. And so those seem to be the two inputs that go into the setting of the timing. So, and the knock sensor input is not part of it. In fact, the knock sensor is a very crude input. It doesn't give you any indication of if it's a strong knock or it's a slight knock or anything. It's either a knock or it's not. And what the ECM does, as far as from my research, what I can tell, is that if the knock sensor is sensing pinging, like pre-ignition for some reason, it sends that to the ECM detects that. It can read the knock sensor. And the ECM goes, oh shit, I got a big problem. Even though I'm following everything in my table, my RPMs and my load, and I think I'm setting the timing at the right place, there's pre-ignition, and that's going to damage the engine if it keeps up. So I'm going to do something to change that. And I think what it usually does is it retards the ignition timing to prevent more knocking. Now, this is good because it protects your engine, but it's not good if it masks a problem, and it is masking a problem. If your engine is pinging when the ECM is setting the timing to the correct advance, that means that maybe your spark plugs are worn out, or you've got the wrong spark plugs, or you're using too low of an octane fuel, or you've got a lot of carbon built up in the head. Various things can change the way the fuel mixture burns and how fast it burns in a cylinder. And if it burns evenly, or if it kind of has a hot spot and burns here and then catches over here. All of those things can cause pinging. And so it's great that the ECM can sense the ping and make an adjustment so it doesn't ping. But if it makes that adjustment, it's no longer setting the timing for optimum power and fuel economy. It's setting the timing to simply avoid pinging and avoid damaging the engine. So my conclusion is, if you bypass a knock sensor or bypass both knock sensors, so the ECM does not have any functioning knock sensors to ever hear. So the ECM will always think there's never a knock. If let's say there was no knock sensors, I believe that as long as your engine is clean, is burning the right kind of fuel, has the right clean, good spark plugs in it, the right kind of spark plugs, it's not going to ping, and your ECM will set your engine timing correctly so that you get optimum power and optimum fuel. Now I could be wrong. I did try to see if I'm not a GM timing engineer. I'm not a GM engine ignition engineer, and the people who program the ECMs are the ones who could say if I'm right or wrong here. But again, based on what I've been able to discover, the knock sensor is not used in the normal running of the engine to help the ECM decide how much to advance the spark. It's only used in a brute force way when it detects a ping or pre-ignition, and then the ECM says, oh no, I got a huge problem here. I got to just not damage this engine by changing the timing. And again, as I said a minute ago, if that's happening, you're going to lose power, you're going to lose fuel efficiency. And yeah, the engine won't ping, but you won't be happy with the way it's running. So the lesson is keep your engine well maintained. The last thing I will say is, and I don't have an answer to this, but the GM engines have 2 knock sensors in them, bank 1 and bank 2. They're both embedded in the head, and they're both going to hear a knock from any one of the cylinders. I'm not sure why GM has 2 of them there. It may just be because they think one might go and you'll still need one to detect knocks. And if that's the case, bypassing one knock sensor is not a problem because the other one is there and it's functioning. On the other hand, maybe the bank 2 knock sensor, which is functioning, and you're bypassing the bank 1 knock sensor, which is to the front. Maybe the bank 2 knock sensor can't hear pinging or knocking from the front cylinders. And I don't know the answer to that question. It's possible. But thought this would be helpful to people who are considering doing this. You save a lot of money by doing it, but I mean, nobody wants to damage their engine. So I hope this has been helpful, and good luck.